Hi everyone, welcome to Duality Repair. This is an ART SLA2 amplifier. The complaint with this unit is that after about 30 minutes of playing, the right channel's protect LED comes on and the output is muted. I haven't done any testing myself yet, so let's get this connected and see if we can replicate the failure. Alright, here's the setup. I have my signal generator generating 5 kHz and 2 volts to the input of the amp. The output from each channel is going to a 300 watt 8 ohm resistor, and each channel is being monitored by the scope. At 10 volts per division, each channel is outputting about 20 volts peak to peak. I'm going to let the amp run in this state for a while and we'll see if we can replicate the issue. That didn't take long, only about 5 or 10 minutes later, and the failure has shown itself. So we can see channel 2's protect LED is illuminated, and if we look at the scope we can see channel 2's output is indeed off. I initially thought this might be temperature related, but feeling channel 1's heatsink and comparing it to channel 2's, channel 1 actually feels a lot hotter. So I'm not quite sure what to expect yet. Either way, it should be interesting, so I'm going to power it off, disconnect everything, take the cover off, and we'll take a look inside. Alright, here we are inside the unit. It's looking pretty clean. It's got a fairly standard layout. We have the giant pancake toroidal transformer here in the center. Each channel has its own board, so channel 1's over here on the left, channel 2 is over here on the right. They look to be nearly identical with the exception of the input, which is handled by the right channel. Each channel also has its own power supply, so you can see a tap coming over here from the transformer to deliver power to the right channel. We have the 2 bulk caps here, and an identical setup over here in the left channel. One thing I'm noticing is that it's going to be pretty tricky to do any live work on the bottom of either of these boards just by the way this unit is laid out. It's very easy to take this top cover off. It only had maybe 6, 7, 8 screws, and the top panel came off. Working on the bottom, however, is going to be tricky because everything seems to be mounted together. We have the boards, both boards and the transformer mounted to the bottom plate. Both boards are also mounted to, of course, the output transistors, which are mounted to the heat sinks. Both heat sinks are also mounted to the back plate and the front plate. So disassembling this shouldn't be too bad, but disassembling it in a way that I can do any troubleshooting or probing on the back of the board live, that's going to be tricky. So with that said, I'm going to do as much troubleshooting and probing as I can from the top before I resort to looking at the back of either of these boards. Since I'm not positive that this is a temperature-related issue, the first place I want to start is looking at this IC right here. This is a protection IC. It's a UPC 1237. Pulled up the data sheet for this quickly. And so I'm going to do some probing related to this IC and see if I can find anything. All right, I attempted to take some measurements on the components surrounding that protection IC UPC 1237, but the right channel just keeps going in and out of protect, and so it's hard to get any reasonable measurements. Based on the timing, I'm leaning more and more towards a temperature-related issue. If we look at the schematic, the protection IC, which is U3, has an output at pin 6. In series with this output is a temperature switch T2. And according to the manual, if the heatsink reaches 194 degrees Fahrenheit, which again seems pretty hot, it does not seem like it's getting that hot even when it's going into protect. But again, that's just me physically touching the top of this heatsink. If it reaches that temperature switch opens up and that disables the output. So effectively what I need to do is measure across that temperature switch just after the unit goes into protect mode, and it should read something extremely high in the kilo ohm to mega ohm range if that switch is indeed open. Unfortunately, you can't see it right here, but the switch is labeled on top of the board here, right behind this capacitor, but it's mounted to the heatsink from the bottom. And so I had to remove this board to try and find where these pins are going. And I did find some suitable test points. So there's a resistor hiding right here that I can probe, and then the other side will be a jumper over here. And so probing at these 2 positions for resistance, just after the unit goes into protect mode, will effectively be measuring across that temperature switch. So I'm going to run the unit again. We'll get it into protect mode, we'll turn it off, and we'll measure, and we'll see what we get. All right, there you go. You could just hear the relay disengaged. Protect LED is on. I'm going to power the unit off and measure the resistance across that temperature switch. I am making good contact, and as you can see, it is open. So that switch is open, and it does appear to be temperature related. However, as I said, and I just did it again, channel 1's heatsink is much, much hotter to the touch than channel 2's. And so I'm really starting to doubt the functionality of that temperature switch itself, T2, on this right channel. So I think what I'm going to do next is attach some temperature probes to each heatsink, and we can monitor the temperature as this unit is running and warming up. And I'm just going to wait to make sure that I am making good contact. We should start to see some measurement on here as the heatsink starts to cool. Yeah, there we go. So we're in the megaohm range and it's rapidly dropping. And we're already down in the ohm range, so it's starting to cool pretty dramatically. If the unit was powered on, it'd almost be out of protect mode by now. So it does appear to be functioning, the switch that is, but I don't think it's functioning properly. So I'm going to get some probes attached to these heatsinks so we can do some more testing. All right, time to get objective with this problem. So I'm monitoring the temperature of each heatsink here. The top temperature here is for channel 1, the bottom is for channel 2. I've had the unit on for a few minutes now. You can see the temperature for both rising. They're tracking pretty closely, but I can see channel 1 is sort of pulling away a little bit from channel 2, which isn't a surprise for me. As I said, channel 1 did seem to be hotter after it's been playing for a while. So I won't bore you. I will skip ahead to the point where channel 2 goes into protect, and we'll see what temperature that's actually tripping at. Again, the magic number, according to the schematic, is 90 C or 194 degrees Fahrenheit. So we'll see what happens. All right, so there you go. You can see channel 2 is in protect, and the temperature is just under 100 degrees Fahrenheit. There's such a big temperature difference here because I've been monitoring this for a few cycles now of going in and out of protect just to make sure that the temperature that it trips at is very stable, and it seems to be right between 98 and 100 degrees Fahrenheit. So warm, but nowhere near the expected 194 degrees Fahrenheit that it should trip at. So as I expected, there seems to be something wrong with that temperature switch T2. So let's take a look at that. Here's channel 2's board, and you can see I've already had the temperature switch here T2 lifted off of the heatsink. It was just mounted with this small bracket here, along with this other thermal switch. This is a 50C rated switch, and this, along with its complement on channel 1, controls the speed of the fan. I've inspected this switch T2, can't find anything obviously wrong with it. Does appear to be the right switch. Looks like it's rated for 90C. So I just went ahead and ordered some replacements. The only thing I can find was a pack of 10, but they're pretty inexpensive at about $1 a piece. So when those come in, I'll replace this one along with channel 1s just to be safe. It's going to take quite a while for them to come in, 2 or 3 weeks. So while I'm waiting, I'm going to do some other checks. I'm going to spot check maybe 5 or 6 electrolytics on both boards. I'll check the ESR and capacitance of those. If there's any marginality with those, I'll probably replace them, if not all of them. I'm also going to pull some, if not all of these transistors here, and use my peak meter to inspect those. A couple of reasons. Number one, the thermal pad on here, they're probably original, so I want to inspect those and make sure that they're in good condition. If not, I'll replace those. And then also I see what looks to be some sort of a burn or heat-related mark in between these two transistors here. It looks like it's coming from that transistor on the left, which is part of the gain stage. Can't quite tell, but either way, it's good reason to pull all these off and just do some checks. So I'm going to start pulling some components and taking some measurements. I didn't find any issues with any of the capacitors or transistors that I looked at, and the transistor thermal pad still looked to be in good condition, so I didn't touch anything other than replacing the thermal switch T2. As you can see, the new style is quite a bit bigger than the old style, in width and height at least, but the depth itself is just barely bigger, and so it still mounts perfectly flush with the heatsink. I also put some new thermal compound underneath both switches. I've been testing the amp for about 45 minutes now, and as you can see, the temperature of both heatsinks is well above 100 Fahrenheit, almost 125 for both. We have channel 1 again on the top, channel 2 on the bottom, and both channels are running just fine, including, of course, channel 2. No protect LED, signal output is still on. And so I'm going to test it for another 15 or 20 minutes just to be sure. But outside of anything happening then, I'm going to say that this thing is fixed. So we'll see you next time.